Okay, today we're going to talk about solving systems of equations using the substitution method. If you remember from last time, we talked about the graphing method, and we found the solution for the system based on where two lines intersected. And if there was no intersection, it was either because it was the same line where they were stacked on top of each other, and we only saw one line graphed, or it was two lines, but they were parallel. So now we're going to look at what happens when we take it off the coordinate graph and we do this algebraically. So the second method for solving a system of equations is called the substitution method. And the substitution method is considered to be more precise than the graphing method. Because if you remember, sometimes when you graph, you're giving really an estimate, whereas the substitution method should allow you to get a precise or an exact answer. This method may also be called the equal value method. And I'm going to change this to green real quick. I just want it to be green. And we're going to talk about why that is. Like, why do we sometimes call it the equal value? Because it doesn't apply to all the times we're doing substitution. Okay, there are 6 steps. So 6 steps are used to guide the solving of a system by the substitution method. So step 1 is isolate. And hopefully we know just in general that the term to isolate means that something is by itself, right? So in this case, what we're looking is to solve one of the equations in the system for one of the variables. Doesn't matter which one. Okay, but we're going to look at the equations and decide, do we want to isolate the y or do we want to isolate the x? It doesn't matter which one we do. In the equal value method, so this is kind of like a subset of substitution, we solve both equations for the same variable. So in regular substitution, we're going to look at the equations and we're going to take one of the equations and solve it for one of the variables, isolate one of the variables. In equal value, in both equations, we're going to isolate the same variable. Step 2 is substitute. And this is where we're going to substitute the expression from step 1 into the second equation. So in step 1, we've isolated one of the variables. So we have y equal to an expression, or we have x equal to an expression. So that expression side, we're going to take that and substitute it in for the isolated variable. So if we isolated the y, that expression will go in where y is. If we isolated the x, the expression will go in where x is. In the equation, the second equation, that we didn't isolate a variable in. For equal value, we set the expressions from both equations equal to each other. And I know this might be hard to visualize right now, but we're going to go through an example of both regular substitution and equal value. So in step 3, after we've done that substitution, we're going to solve. And we're going to solve for the first variable in the equation we created in step 2. And we're going to use the 5 steps for solving equations. So I hope you guys remember I told you we're going to solve equations for the rest of the year. 5 steps is not going away. Okay, so those are the first 3 steps, and that is going to get us to the value for one of the variables. But in a system, there's 2 variables, and we need to find out the value of both of them. So after step 3, we're going to focus on solving for the remaining variable. So in step 4, we call this second variable. Okay, because we found the value of one, now we got to find the value of the other. And here we substitute the answer that we just got in step 3 into one of the original equations in the system. Then we still use the 5 steps to solve for the second variable. So let's say we found x first, now we'd be finding y. If we found y first, now we'd be finding x. After that, right, we're going to have the value for both of them. We'll have the value for x and the value for y. By the way, if we call them A and B or C and D or F and G, it doesn't matter. We're going to have a point, right? We're going to have the location of a coordinate point on, if we wanted to graph it on a graph, that is going to be the solution for the system. So we're going to write the answers from step 3 and 4 as a coordinate pair. Okay, and here when we say follow alpha, that's because if they don't use the variables x and y in the system, maybe they use, like I said, A and B or F and G or whatever 2 alphabetical letters they use, we always follow the alpha, meaning whichever letter comes first in the alphabet would be considered like the x value and the second one would be considered the y. So in step 6, final step, we need to check our work. Okay, and how do we do that? We substitute the point from step 5 into an original equation not used in step 4 and do the math. If we get a true statement, then we have a correct solution. Here are some examples of where we would kind of use the equal value substitution method versus the regular substitution method. So here, equal value, y is isolated, same variable isolated, or same variable with the x's isolated. Whereas on the substitution side, we can see that in this example, y is isolated here, but there is no variable isolated in the second equation. Same with the second example down here. So we're going to go and solve these examples. We're going to do 2 on the video, and then we'll do 2 in class. So let's go to slide 14, and we're going to classify the system. Remember, to classify it, we need it to be in slope-intercept form first. These both are in slope-intercept form. So I can look and see they don't have the same slope. So based on that, I know that they are going to be consistent and independent. This is an equal value situation. So in both equations, y is isolated, so I need to set the expression from each one together. So I'm going to take the first one, I have negative x plus 3, and that is going to be equal to the second expression of x plus 1. Now I need to solve for x because that's the only variable currently listed. So I'm going to add x to both sides. Right, so I've just accomplished step number 1 and this is step number 2, right, when I set them equal to each other. Step number 3, solve. I'm left with 3 equals 2x plus 1. I'm going to subtract 1 from both sides. I'm going to get 2 equals 2x. Then I would divide by 2, and I would get 1 equals x. So I found the value for x. I know x is 1. But remember, my goal is to write a coordinate pair. So this is not enough. I have to keep on going. So I'm going to take step number 4. I'm going to take the value I just have for x, and I'm going to substitute it back into one of the original equations. So I'm going to use y equals, I'm going to put this in parentheses so I know this is the substitution value, plus 1. So I'm using that bottom equation, y equals x plus 1. And 1 plus 1 would be 2, so y equals 2. Writing the coordinate pair, x's value is 1, y's value is 2. So now I need to check my work. So I'm going to use the other equation I hadn't used before, which is y equals negative x plus 3 to confirm that my work is correct. So 2 equals negative x plus 3. And that is going to give me 2 equals 2. That's a true statement. So I know that my solution is correct. So I'm going to put my solution over here in this big box. So my solution is 1, 2. Okay, so that tells me that for the system, y equals negative x plus 3 and y equals x plus 1, that the solution that they both share is 1, 2. And if I graph these lines, that's where they would cross over at. Now let's look at an example of non-equal value, which is example 3. Now, if I look here, I'm not ready to classify the system because I don't have this second equation written in slope-intercept form. So I'm going to wait to after I solve it to classify the system. So I know y equals 4x, right? This would be no different than if it said y equals 1, right? I would be able to take the y out of that second equation and put 1 in. In this case, so I'm not going to put in 1, I'm going to put in 4x. So step 1, isolate, that's been done for us, right? I don't have to do that work. They've done it for me. Step 2, substitute. I'm going to substitute this 4x into where the y is here. Because I know y is equal to 4x. Therefore, 4x and y are interchangeable. They have the same value. Okay? Okay. So let's go ahead and do our work. So now I know 3x minus, instead of y, I'm going to put in the value for it, which is 4x. And I've put it in parentheses so I don't forget that there's a subtraction sign in front of it, etc. Because if it was a negative 4x, then I'd wind up with a double dash and all that kind of stuff. So 3x minus 4x equals 1. So 3x minus 4x is negative x equals 1. I can't have a negative on both sides, so I'm going to divide by the negative 1. In other words, remember when we talked about flipping the sign of everything? So x is going to equal negative 1. Right, so I've just accomplished steps 1 through 3. Now I need to take this information and I want to substitute it into an original equation. Okay, so if I had to do work to isolate one of the variables, I'd go back to before it was isolated. So I'm going to pick this y equals 4x. So y equals 4 times the value of x is negative 1. And I get y equals negative 4. So write my coordinate point of negative 1, negative 4. And now I'm going to substitute it into the 3x minus y equals 1 to see if I was correct. So 3 times negative 1, because that's the value of x, minus the value of y we have is negative 4, equals 1. So 3 times -1 is -3. A negative times -4 is +4. And in fact, 1 does equal 1. So I am correct. So looking at this, because I've gotten a solution, I have a coordinate point as a solution. Because remember, if it was no solution, obviously I wouldn't have one coordinate point, they'd be parallel. And if it was all solutions, it would come up as infinity. And we're going to talk about like what those look like in class when you're solving them algebraically. They're going to look very similar to when we solved equations and came up with no solutions or infinite solutions. So the system is going to be consistent and independent. Now, this is the classification of the system. This is not the solution. The solution is a coordinate point, infinite solution, or no solution. Those are the options for the actual solution. Down below, we're going to have -1 and -4. Ooh, that's not what I wanted, so we're going to undo that. Take away some of the spaces here. Okay. -1, -4, right here, same point. That's my solution. So that's how we do the substitution method. And as I said, we're going to go over the other 2 examples in class, after which you have a couple of GPs to complete, GP 3 through 5, that involve some matching and solving and that kind of thing.